Hi, welcome to another episode of Yummy Data Science. In the last episode, I talked about readmissions, and I talked specifically how it is important to have predictive machine learning models and to take prescriptive actions. Because not only are you saving money, say from the perspective of the hospital or the health insurance, but you're also improving your health outcome and you're doing it at a lower cost. And in the last video, I also talked about how I take the data, I make it very simple, create a few test edge cases, and then I write down what I need my final data to be based upon the test data that I've created. And I do this in a document. It can be done in any other uh, I do it in a Word document. It can be done in any other form as well. And so what that creates is almost like a test driven development. I know my test data, and now any code that I write has to pass that. So if you haven't watched the previous video, please do so, and we will pick up from where we left off. So we are going to be reading the inpatient encounters file. Recall that this is inpatient data that has come from inpatient claims, and we have changed the structure of the file so it is no longer so wide, and we are simply taking the principal diagnosis code from the 26 or so ICD codes, and we have greatly simplified that the structure of the file. So it has the dates of admission, discharge, principal diagnosis code, DRG, cost, length of stay, etc. And so now our motive is to create that readmit flag. Okay. So in cell 2, I'm reading my file, and then I'm looking at the length of the file. So I know it has around 10,000 observations where the year is greater than 2019. And then I do a little bit of I want to get rid of the ER visits, and I want to do some formatting of, I'm creating admit and discharge dates, and then dropping some variables. So doing some housekeeping to get ready. And now I have around 3,000 rows. And now what I'm going to do is, so you see readmits, I only need to calculate on those encounters, on those patients who had more than one admission. And a vast majority of the patients in my file only had one admit. So why do my algorithm on every one? So I'm going to break up the data set into two pieces where the number of admissions is 1, because I know that the readmit flag there is going to be 0. And then where its number of admissions is more than 1. So here I'm creating the number of admits, and I'm taking that. And in the next cell, if number of admits is equal to 1, I'm putting it in the readmits 0 data frame, and then creating the readmit flag, which is equal to 0. And now I'm ready to, with that smaller data set, I'm ready to do my algorithm on it. And you can see the flow. It's a big problem. You might have millions of rows, but by filtering the rows, funneling the rows, you are saying you are doing your most expensive operations on the least amount of data. So now what I need to do before I begin, this is synthetic data. So the admission and discharge records, date-wise, don't always line up. Sometimes the admission is on the exact same day or even before their previous discharge. So I am using an algorithm to fix that, quote unquote fix. And this is simply adding the appropriate days to the admit or the discharge date. And this was generated by AI, and it's just creating the time delta between the admit and the discharge. So a current row, loc is I, loc minus 1 is the previous. And it's making sure that it's the same Ben AID over in line 1, the if statement. is making sure that it's the same Bene ID, and then it is also making sure that it adds that time delta to the admit date and the discharge date. So it's making sure that my dates line up. And in the below, I'm using the assert to test my code and catch errors. And if there are any violations of the assert statement, the program is going to halt. And here I'm testing two. So here the assert statement is testing if the Bene IDs of two consecutive rows are different, in which case it would pass. Or if the Bene IDs are the same, then it is testing that the admit date of the current is equal to, is greater than the discharge date minus 1, discharge date of the previous admission. And then if the assert statement does catch records, it's going to print this. And it didn't do anything, so I know that it's all set. Now now that I've fixed my dates, I am ready to sort my data frame by Bene ID and admit date, and then I'm going to create my readmit flag. So, and this is saying, this is another for loop, and in the for loop, I'm saying that I want to take groups of observations that have the same Bene ID. So each group in this for loop is my row of observations that goes with Bene ID. So I'm saying for Bene ID and group, I actually don't need Bene ID in here, but for clarity, I put that in there. Okay. So for each that little group data set, run another for loop, which goes from 0 to length of the group minus 1. So if the group has 4 observations, you only want to run it to 3 because you don't care about the last observation. And so if loc plus 1, so if the current plus 1 admit date is the difference between the current one plus admit date minus the discharge date of the current record. If that is less than 90 days, then it is indeed a readmit. Okay. So all it is saying is, like, look at the one here. It is saying, okay, let's look at the next observations. That's I plus 1. And the admit date is September 13th. If the difference between September 13th and August 23 is less than 90, then the readmit flag of the ith row should be 1. And that's exactly what's happening here. So then I do a quick sum on the flag, and I also did a little bit more testing, which I deleted for the sake of clarity and flow of the program. So now I know I have 833, so I'm pretty much done. What I did is then I concatenated my readmits 0 back into my inpatient readmits. And then I wrote it to a file. And now I'm ready to add more features to it and do my machine learning. So in the next video, I'm going to show you machine learning algorithms, such as starting with logistic regressions and doing decision trees, random forests, gradient boosting trees, and so on. So I'm going to cover that gamut of machine learning models. Thank you for listening.